right, this is Unit 3, Lesson 2, Part 1, and our topic is graphing absolute values from tables. Kind of a long. Graphing absolute value functions from a table. Sorry. Long title there. Graphing absolute value functions from a table. So that's what we're going to be working on today. So we're going to introduce, or I guess reintroduce, the idea of an absolute value function and then talk about just a quick little intro of how to graph them. So an absolute value function, you write it like this. We've got f of x, that's always our function notation, equals the absolute value of x. So you see the x that you always see in those two vertical lines. That's the absolute value sign that we'll be using. So we are going to just fill out one quick little table, look at the original function, and then talk about how that function is going to change. So these are some different x values. We're going to plug them in here. So the absolute value of -3, remember absolute value always comes back positive. So the absolute value of -3 comes back as +3. Absolute value of -2 comes back as +2. That makes this +1, and then absolute value of 0 is just 0. And then these three, +1, +2, +3, because they're already positive, it's not like you're changing the sign to its opposite or anything like that. You're just taking the value, but not the sign. So the value is just 1 and 2 and 3. These values are 3 and 2 and 1. So these are always going to come out positive or 0. So now you've got these 7 points. We're going to plot them. So -3, +3 would be right here. -2, +2, right here. -1, +1. This middle point is 0, 0. That's just right at the origin. 1, 1. Then starts to go back up this way. 2, 2. It's right there. And our last one, 3, 3. So plot those points. You should have this V-shaped curve that looks like this. So we're going to connect the dots. Goes off to the right like that. It would just keep going through the grids. Off to the left like this, right up through that upper corner. So that's the shape of like the original absolute value graph. We'll talk about this later in the chapter, but we call that the parent function, kind of the original, before you start moving it or changing it in any way. So the domain. Domain is what x values you are allowed to plug into this graph. You can plug in any x value that you want. There are no restrictions on what you're allowed to plug in. So we use that symbol, that double blocked R, which stands for all reals, meaning you can plug in anything that you want. The range is just what you get out of the function in terms of y values. So if you're looking at these y values, remember we said no matter what you plug in, the outcome is going to be something non-negative, so 0 or up. So we say y can be anything greater than or equal to 0. Nothing negative comes out of this original absolute value function. So the graph looks like a V. You've got this V-shaped curve, and then the turning point where like you're headed in this direction and then it turns around, it goes back in the other direction. We call this point right here the vertex. And we will be using that vocabulary throughout the next couple sections. So know what we're talking about when we say the vertex. So there's just kind of a little intro, and I've got this step-by-step here for you to graph by using a table. We're going to walk through as we do number 1. So to create a table of values, it's best to place the vertex in the middle because the vertex is always going to be kind of the center point of your graph, like you're going in one direction and then it turns, it goes the other way. So we need to figure out where the vertex is. That's always going to be the first step in this process. So step number 1 here says find the x value of the vertex. So what you do for that is you take the expression from the inside of the absolute value bars and set it equal to 0. So for number 1, we take this, the x minus 4, just what's inside. You might come across problems where there's stuff on the outside too. You don't want to use any of that. Okay, so you take just the expression from the inside, set it equal to 0, and solve. So to solve this one, oops, there we go. X minus 4 is equal to 0. I would add 4 to both sides, and I get x equals 0. So that was my step 1, just taking that expression from the inside, setting it equal to 0, and then solving. Step number 2. This is very important because we want everything to be centered at our vertex. Place this value in the middle row of your table. Okay, so the middle row is where x equals 4 is going to go. So that is going to go right there on our table. And then continuing on with step number 2, number up and down, and then complete the graph. So if this is 4, then before that we would have 3, 2, 1. And then again, back to 4. We can also number up, 5, 6, 7. Then complete the table. So we're still kind of working on this step 2 right here. So completing the table means we are going to plug those values on the left-hand side into the equation that we have up above. So I'm going to start by plugging in 1. So if I plug in 1, 1 minus 4 is -3, and the absolute value would be +3. Then 2. 2 minus 4 is -2. The absolute value would be 2. 3. 3 minus 4 is -1. The absolute value would be 1. 4 minus 4 is 0. 5 minus 4 is 1. And if it's positive already, then you just know that that's the value that you're going to put down on your table. Same thing with 6. 6 minus 4 is 2. And 7 minus 4 is 3. So we have those 7 values that we can plot. And step number 3 right here says graph. So you just take those 7 points, plot them onto your graph, and then we'll talk for a moment about how it's different from the original one that we just put up above. So 1, 3, we go over 1, up 3, 2, 2, 3, 1, 4, 0 would be right on the axis there. 5, 1 is where we start to go back up, because remember that was our vertex, that was our turning point. 6, 2, and 7, 3. So we've got 7 points, plenty to see with that V shape that we're looking at. So start at the vertex, go up in both directions like that. So this looks very similar to the other one, except where you can see this one starts right at the origin like this. This one moved over 1, 2, 3, 4 units, and that's because the vertex moved over to a +4, but other than that, the general shape of it looks exactly the same. So that's what that x minus 4 did, is it shifted it over like that. So the domain. Domain is still all reals. Fun fact, it's going to be all reals for every single one of these absolute value graphs that you will ever see. And then the range is going to change based on where your y values are. So this low point right here, this point has a y coordinate of 0. You can see it on the graph, you can see it on the table. And so it starts at 0, sort of, if you think of it that way, and then it only goes up from there. So same range as the original one. Y values can come out anything greater than or equal to 0. All right, so that's our first little intro on how to use the table. On the next page, we're going to just look at a few more, some different changes that you can see. So let's look at number 3 next. All right, so number 3 is a little bit different. The absolute value only has an x inside, and then the +5 is on the outside. So let's see how that's going to affect our table and our graph. So step 1 was you want to figure out where the vertex is. So you take just the expression from the inside and set that equal to 0. So the +5 is not part of this step. You only want the part that came from the inside. So that x value becomes the center of your table. Number up, number down. And then once you have all those x coordinates set up, then you're going to take those x coordinates and plug them into the equation that you have up above. So absolute value of -3 is 3, and then +5 comes out to be 8. -2, when I plug that in, the absolute value is +2, +5 gives us 7. Plug in -1, absolute value comes out as +1, and then +5 would be 6. Absolute value of 0 is 0, +5 is 5. And that's the vertex, then my point should turn around from there and go back in the other direction. So absolute value of 1 +5 would be 6. Absolute value of 2 +5 would be 7. And finally, absolute value of 3 +5 would be 8. So you can see that this point right here is the vertex. So the points go down, they hit that point, and then they go back up from there. So let's plot them. We have -3, 8. So over 3 and then up. 1, 2, 3, 4, 5, 6, 7. So it looks like right up at the top there. -2, 7. You can move down just 1 unit to 7. -1, 6. 0, 5 would be right on the y-axis there. And then we know that that's the vertex, so that's where our graph is going to turn around. So 1, 6 goes back up. 2, 7 goes up again. And 3, 8. So we start at the vertex. You can see this graph goes up on both ends like that, makes this V shape. So then we fill out the domain and range. So the domain Don't even really have to think about it, because you should just know that it's going to be all reals for every single one. And then for the range, that's the y coordinate. So the y coordinate, you want to see where they kind of begin. So the vertex is at 5, and then all of the points go up from there. So instead of being greater than or equal to 0, because of this shift upwards that we had, it is now greater than or equal to 5. This point is the lowest point on the whole graph, and it's got a y coordinate of 5. So that's what your range would be. So that's number 3. We're going to look at the one right below it as well. Actually, let's talk for a quick moment here. This one is different from the original. Let me show you the original. There's the original. Here's our new one. You can see instead of starting at the origin, it starts 5 units up. So that must be what that plus 5 did, because it was on the outside of the absolute value. It moved it up 5 units. So let's talk about number 5 right here. Step 1, figure out where the x coordinate of the vertex is. So take just the expression from the inside of the absolute value bars, nothing else. Set that expression equal to 0 and solve. So I would subtract 1 from both sides. Gives me this, x equals -1. So I know when I'm creating my table, it needs to be centered at -1. So I put that right there. From -1, I can go up, 0, 1, 2. I can also go down, -2, -3, -4. So making sure it's centered at that vertex, which we found right here. And then you plug the values in. So plug them in here. -4 plus 1 is -3. The absolute value is 3, and then you have this negative sign. So the negative signs don't cancel. Like, think order of operations. You have to actually take the absolute value first, and then that negative is kind of like multiplying by a -1. So the absolute value makes it +3, but then this makes it -3. Okay, so let's do the same thing with the next one. When I plug in -3, -3 plus 1 is -2. Absolute value is 2, but then this makes it a -2. And remember, those negative signs do not cancel. You can't cancel like into an absolute value bar. -2 plus 1 is -1. Absolute value would be +1, and this makes it -1. -1 plus 1 is 0. So no matter what, it's just going to come out to be 0. There's no such thing as a -0. Then 0, 0 plus 1 is 1. Then we make this a -1. 1 plus 1 is 2. And we make this a -2. 2 plus 1 is 3, and we make that a -3. So notice you should have the same sort of symmetry that you've seen in your other tables so far. This should be the middle point, that's your vertex. So let's plot. We have -4, -3, -3, -2, -2, -1. -1, 0 is right on the x-axis right there, and we know that's going to be the vertex, so it's going to be the turning point. So here's something we haven't seen yet. 0, -1, look at this one. It's going to be that same V shape, but it's upside down. So we'll finish talking about that idea in just a moment. 1, -2, and 2, -3. So still do what we did before. Connect the dots, go off in this direction, this direction. You can see the vertex in the middle, but this one's upside down. The reason it's upside down is because of the negative out front. Then what the +1 did is it moved it over 1 unit to the left. And so we'll continue talking about these transformations, but those are the 2 things that changed in the equation, and those are the 2 things that corresponded and changed with the graph. So domain all reals, you can always plug in any x value you want into an absolute value function. The range is based on this point right here. All right, so this y value is 0. The weird thing is here, that is actually the highest y value. Okay, so this, it starts at 0, but then it goes down. So when you're doing the range, you're going to say y is less than or equal to 0 instead of greater than, because it starts at 0, but from that point it goes down. All right, so we see that one. We're going to look at one more. We're going to look at the piecewise function over here. So number 8. Revisiting the stuff that we did with piecewise functions before. The only difference is that one of these now is an absolute value graph. So we're going to begin with that one, show some work for it, do our little like pencil and erasing thing. Sorry for all the noise, I'm trying to grab something out of my cabinet. So starting with this one right here, we are going to make a little table for it, do our work. So you take the 2x from inside and set it equal to 0. So for this, you divide both sides by 2, and we end up with x equals 0. That's where the vertex needs to be. It's going to be the center of our table. So 0 goes right in the middle. From there we go up and down. And we do this just the same way that we've done all the other ones. So now plug these in here. -3 times 2 is -6. Absolute value is 6. -4 would be 2. Then the -2 times 2 is -4. Absolute value would be 4. -4 would be 0. The -1 times 2 is -2. Absolute value is 2. -4 is -2. 0 minus 4 is -4. 1 times 2 is 2. -4 is -2. 2 times 2 is 4. -4 is 0. 3 times 2 is 6. -4 is 2. So those are my points. Remember, when I do piecewise, I'm going to do them in pencil and then figure out what portion I'm going to keep. So plot these first. -3, 2. -2, 0. -1, -2. 0, -4 is on the axis here, and then that's our turning point. So now, after our vertex, they go back in the other direction. 1, -2, 2, 0, right back on the x-axis there, and 3, 2. So that is my absolute value graph. Make sure you're only doing it in pencil until you know what you're going to keep. So then we go back here, just for the x-coordinates that are less than or equal to a -3. So find the -3. -1, 2, 3, which is right here on the graph. Less than or equal to means that should be a closed circle, and then you just want to keep the part that's less than that, which means to the left of that point. So I'm going to erase everything else, which is weird because it actually kind of takes away the shape that makes it look like an absolute value graph. Okay, so I'm just keeping this part, closed circle, and then just the part that goes up here. So that's the first part. Then this. Second graph, -5 would just be a horizontal line. So I go down 1, 2, 3, 4, 5. In pencil, you can see it's just a horizontal line. And then look here between -3 and +2. So -3, 1, 2, 3, trace it down to the graph. So I don't want anything before that. And then up to +2, here's +2. Down here, so I don't want anything after that. So it's just going to be like this little segment of a horizontal line. They're both going to be open circles because they're just less than. So open circle at -3, open circle at +2, and just this little horizontal segment in between. Third and final piece is x minus 2. That one's linear. So start with a y-intercept at -2, and then a slope of 1. So we go up 1 to the right 1, up 1 to the right 1. We keep on going there. And then connect the dots. It's greater than or equal to 2, so I know it's going to be off to the right anyway, so you don't have to be super accurate to the left here. So graph looks like that. Just do it in pencil first until we figure out what we're keeping. We're keeping just the part that's greater than or equal to 2. So find x equals 2, which is right here. It's right on the graph. Keep a closed circle here and only keep the part to the right, which means erase this part. So closed circle here. Go off to the right. So that's what the graph itself should look like. Let's finish off with the domain and range. For the domain, you can look here. Like nothing is completely cut out. Like this one cuts out the -3, but this one includes it. This one cuts out the 2, but this one includes it. So eventually all of the x values get covered. Every once in a while you see a situation that's different than that. And then the range is just the y values. So if we look at the y values, remember you look for highs, lows, gaps. So it hits this value right here, like it hits just the -5. But then there's a big gap and it doesn't hit another y value again until it gets here, which is a y value of 0. But then from there it goes up forever. So it hits -5 and then it jumps up to everything greater than or equal to 0. So that's what it looks like when you incorporate absolute value into a piecewise function.